Zinc is also more reactive than copper. Zinc is even more reactive than iron. Zinc plus copper sulfate will give zinc sulfate plus copper. And again, in all displacement reactions, the reverse reaction never takes place, because it's always a more reactive metal displacing a less reactive metal. So the less reactive metal, when released, cannot displace the more reactive metal. So that is why these are not reversible. So this reaction can take place. Again, lead, and not always copper sulfate, can be copper chloride. It will form, lead is also more reactive than copper, so it will form copper and lead chloride. You can have many more examples of different salts and different metals. So this is about our displacement reaction. Okay, one important thing is that copper sulfate is commonly called blue vitriol. Ferrous sulfate is commonly called green vitriol. And zinc sulfate is known as white vitriol. Just for your information, maybe they can ask sometime that write the formula of blue vitriol, or they can ask in the question that iron reacts with blue vitriol. So you have to know the formula you have to know what is called blue vitriol for answering that question. So this is just few facts. After displacement, come to a type of reaction called double displacement. Now in double displacement reactions, in displacement reaction we had one, or let us take A plus mx giving ax plus m, where A was a metal, m was another metal with x as the radical, and mx was the salt. And this A displaced m and formed ax, and m was left alone. Now, in double displacement reactions, it's two salts reacting. It's ax plus my. It will give, and they just exchange their radicals. It will give ay plus mx. So this is the double displacement reaction. Just change their radicals. Give you an example. Suppose you have Na2SO4 and you have barium chloride. These two will just change their radicals. This will become BaSO4 and this becomes NaCl. And for balancing you just need a 2 over here. You can just check it. And this barium sulfate, it is a white solid substance and it settles down at the bottom of the test tube. And such a substance which settles down at the bottom is called a precipitate. And the reaction is called precipitation reaction. So if they ask you a question like, there are two salts X and Y, when they reacted there was a precipitate, and the precipitate was that of of a barium salt. So what are X and Y? So you can just write that X was Na2SO4, Y was barium chloride, the precipitate was BaSO4, and give the reaction. It's a white precipitate. Now there are other colored precipitates also, like they may ask you about this reaction. Lead nitrate, a lead nitrate solution was there, and a potassium iodide solution was there, and they were mixed, and there was a precipitate. There was a yellow precipitate. What was that precipitate? The reaction is they just exchange these radicals and they form KNO3 plus PbI2. If you just balance this will become 2, this becomes 2. Okay. And the yellow precipitate is that of this lead iodide. Or they can ask you, you mix lead nitrate and potassium iodide solution, what do you observe? Observation is that there is a yellow precipitate of lead iodide, and you give the reaction, of course. That is a very mandatory thing. You have to always give the reaction. Now in double displacement, what actually happens is that both the salts are in aqueous form. So they are not actually in, they are actually in their ionic form. So when you have Na2SO4 plus BaCl2, you actually have Na plus SO4 2 minus, Ba2 plus and Cl minus. Just have these ions. So Na, actually Ba goes and combines with SO4 2 minus and forms BaSO4, which settles down, has the precipitate. You write PPT for precipitate. And Na plus and Cl minus, they form NaCl, but actually they just stay in their ionic form because it's just aqueous solution. So they will not form this solid NaCl, they will stay in their ionic form. This BaSO4 will combine and settle down as the PPT. So in double displacement reaction, it's just the exchange of the radical ion. This Na plus radical goes and combines with Cl minus radical, Ba2 plus radical goes and combines with SO4 2 minus, Ba2 plus ion goes and combines with SO4 2 minus ion. So that is the theory behind double displacement. They are just ionic combinations.